Hello everyone, welcome to Spark Study. In this video, we'll continue the root locus technique and we'll learn about the construction of root locus. That means the transfer function is given, and from the transfer function, how do you create a root locus? I repeat, what is root locus? It is the locus of all the roots, right? That means I told you that gain is k, and we have for a transfer function g of s. Let's see, g of s is in series, I mean cascade with k, so that when you can tune the value of k, it's like a volume control button. So according to a desired output, you can control the value of k. Fine. So by changing the value of k, we can have different roots, right? So if you join all the roots, it create a path that is called root locus, and we'll study how to design the root locus. We have many techniques, I mean many steps to follow the root locus. So as of my knowledge, I have seen basically three different types of root locus. You also follow this step. This is a thumb rule, because root locus is a technique. It is easy for you to understand, but while you are facing some problem in your exams or anywhere, then you will get confused which type of root locus should be. So technique remains same or the step remains same, but the thing is for each and every type, I mean I told you three types, so all the types having a different way to follow. Let's say we have 10 steps to draw a root locus. Might be first type of root locus need only 5 step, and second type root locus might need one more step, and the next one of root locus may need one more step, like that. So that so you need to learn all the steps first. Fine. So you can see we have this is a kind of root locus. So you can see, if you see that, let me get my highlighter. Okay, laser. Let's see, this is the imaginary axis. This is the imaginary axis called j omega axis, and here it is the real axis or sigma axis or real axis. Okay, so s is equal to sigma plus j omega, and I told you put s value to j omega because I do not consider the real value, so I just consider the imaginary term. That's why I told you apply the value of s equal to j omega. So here you can see that this is the path of root locus, this one, right? This one the path of root locus. Similarly, we have another root locus over here. So this arrow mark indicate the root locus. Similarly, from here to here and here to here, so there are many branches of root locus. That means the thick black line indicate the root locus, the locus of roots. So instead of, see, I told you the poles are marked as a cross sign, and here can see it is a cross sign over here, it is a cross sign over here, it is a cross sign over here, and here also. So you can ask me, sir, if cross sign over here is there, one more is there, then why the total line is there? So if you tune the value, you can have different cross sign in the total line. So that if you combine all those cross sign, then you can get a thick line over here. The locus of lines. So this kind of lines, one is a kind of root locus. So either this can be like this, and also it can be like this also, like so here also, if you get here also. So always remember, a root locus is like mirror image of real axis. So if you consider this is a real axis, it is a mirror, then whatever you draw here, that should be reflected over here. Okay, I will study in the rules. You can have to understand. So this is a kind of root locus, and let me make you understand that this is a point. It's called centroid. So from the equations you can easy to find the centroid. After finding the centroid, we have to find this angle. So once you find this angle, put dot line. So we'll study what is this dot line called. Basically it's called asymptotes. Okay, as this is the centroid, this is the asymptotes, and all these thick line is called the root locus. Okay, so this is the first kind of root locus. We have another one, the second one here. It is another kind of root locus. I told you root locus is the mirror image in with respect to real axis. You can see if this is a half circle, the the mirror image will be in this one, okay, downside. So consider this is the mirror. So it should be whatever you draw in the top side, it should be reflected in the bottom side always. Anyhow, this is second kind of root locus. You can see here a very good thing. So this is a cross sign, this is a cross sign, that means two poles are there. So okay, so the root locus usually divert from in between two poles. If there is two poles, conjugative poles, the root locus try to come out. Okay, and if this is 0 over here, some other 0 over here also there. So if there is 0, you can see the root locus try to converge here. Okay, so we will study this thing in the next video or somewhere else. And one more type is like this also. It starts from somewhere in the complex conjugate and go like this, and we have also the mirror image. It is like here. So we also have the this kind of like centroid, asymptotes. So from this three figure, it is very clear that if my root locus will be kind of a circle, we no need to find out the center and the asymptotes. So not any use. That is why I told you I have some rules to follow to draw the root locus. But for some type of root locus, I do not need to follow some actually roots. So one more thing, you can draw this root locus freehand. This freehand drawing. No need to put any value. So if you get this point, you just join this line. But this should cross this imaginary axis in some point, na? So we need to find out what is the value of that point. So we also have the equation or the formula to solve this problem. So have patience, we'll study one by one everything, don't bother about that. So the point here, this is the point from where the root locus come out. This is called it's having a name. Similarly here, this is a point, it's also coming out root locus, it having one name. So we'll study all those things one by one. Okay. So the first rule, the rule number 1, this is very important rule. You should remember this rule always. The rule says the root locus is symmetrical about a real axis. This is very important. If you do not remember this thing, you do not learn this root locus technique. So total rule number 1 is from here to here, it is an explanation, but this is the rule actually. What is that? The root locus is symmetrical about real axis. What does it mean? So I told you this is the imaginary axis. Let me change the color. Okay, so let's say this is the imaginary axis and this is the real axis. Whatever you draw, if you draw this is a root locus, I told you it is symmetrical about real axis. What is real axis? This is real axis. Symmetrical means mirror image. So that this should be another line of root locus. If you draw root locus like this, then another root locus should be like this. So whatever you draw, if you draw like this circle, half circle, then it will be like this. That means this real axis behave like a plane mirror. So you know the behavior of a plane mirror, you study in physics, +2 physics. So it is very clear that the root locus is symmetrical about real axis. You remember this always. Fine. Then after, what it say that as the poles and zeros of open loop transfer function are either real or complex conjugate or combination of both. What does it mean? I told you from the beginning that we will deal with closed loop transfer function only in Routh criteria. Except Routh criteria, whatever we are going to study, we all deal with the open loop transfer function. That means the technique final answer will give about the closed loop transfer function with unity feedback, negative feedback. But the step or the transfer function we need to solve, we need to focus on the open loop transfer function. Clear? So we have an open loop transfer function that is called OLTF, and from the open loop transfer function you will find some poles and some zeros. You know how to find the poles and zeros. Poles, to find poles we need to equate the denominator to 0 and find the value of s. Similarly, to find the zeros we need to equate the numerator to 0 and find the value of s. So these are the procedure to find out the poles and zeros. And I told you poles may be real or imaginary or complex conjugate. Let's say all the poles lie in the real axis, then it is a real pole. If the poles lies over the imaginary axis, it is called imaginary pole. If the poles lies in quadrant, somewhere in this quadrant, then it have combination of both real and imaginary term. That is why you can see if one pole over here, then one pole must over here. That is called the complex conjugate. As my poles create conjugate, similarly my locus of poles also conjugate. That means it should be symmetrical. Clear? So these are always located symmetrically about the real axis. From the beginning I told you, if there is a pole over a real axis, it is possible to draw another pole? No. But if the pole is imaginary axis over here, then it must have another pole over here, negative pole. I told you from the beginning. Similarly, if you have a pole over here, it must draw another pole over here. So as the poles having this genetics property to regenerate another pole in the same distance from the origin in the down half or bottom half of the S-plane, this also the technique for the drawing for the root locus. The root locus also follow the same thing. Okay, and since the root locus starts at k equal to 0, I told you, okay, let me draw one more thing. Everybody having the doubt, like asking what is the k and what is. So I told you this is the summing point and this is my r of s. Okay, this is my r of s, and we have something called g of s, that is called open loop transfer function. Okay, g of s, and the output of g of s will give the c of s, that is the output. Okay, and we also have one feedback path which is called h of s. H of s might be 1, so it is called as the unity feedback. Okay, and obviously the feedback is a negative feedback, don't worry about that. Okay, so it's negative feedback. But what happened, I told you, so this is g of is constant, h of s is constant. To control the c of s, we need to change the input. We need to control the input. Let's say if do not have the control strategy in the input, so what to do? So scientists have done one more thing. They have put a gain block over here. The symbol of gain is like this, and they have represent this is by k. Okay, so k can be adjusted. So let's say in your radio or television, earlier television or analog or volume amplifier, you can see there's a button or there's a knob, you can rotate it. So by rotating you can change the gain. So once your gain increases, your loudspeaker voice increases. Similarly, to adjust your output, you can have a control of k. That is why it's called adjustable gain or k. So what is the minimum value of k, gain k? So what is the minimum value of the volume? Its volume starts from 0 and go up to some maximum value. Let's say 5, 1, 2, 3, 4, 5, like your ceiling fan regulator. So 0 means off. So k value can be vary from 0 and it can go up to infinite. Okay, as my control system says. So since the root locus starts from at k equal to 0 from the open loop poles. Remember, k equal to 0, that is the open loop poles. So root locus always starts from poles. Which kind of poles? Because we are following the open loop transfer function, so root locus always start from open loop poles. Fine. and it terminate at open loop 0. I repeat, root locus starts from pole and end in 0. Which kind of pole? It is open loop pole and open loop 0. So open loop 0 or open loop poles comes from k value. So when the value of k equal to 0, it indicates the open loop poles. When the value of k equal to infinite, it becomes the zeros. You just try to understand how it becomes. Let's say k into s minus a. Okay, k into s minus a divided by s minus b. Fine. So I told you, what I told you, when I make k equal to 0, it give a pole. How? So if you make k equal to 0, that means this total term becomes 0. Fine. If you make this k equal to 0, then this total terms makes 0. But when if you make k equal to infinite, how the k value becomes infinite? Unless you make the denominator to 0, the k will not become infinite. Not the k, the total term will not become infinite. So with that concept, we can find out the k equal to 0 means open loop poles, k equal to infinite means open loop 0. You try to make yourself understand. Okay. So therefore, the root locus is always symmetrical with respect to real axis. This is the point to remember. Root locus is symmetrical about the real axis. Fine. What is the real axis or sigma axis of the S plane? Fine. So thus, we only need to construct the upper half of the root locus. Okay. What we need to do? We need to at least construct the upper half of the root locus. Once we construct the upper half of the root locus, we can make a mirror image for the lower half. Then we can easily draw the mirror image of the upper half in the lower half of the S plane. That is my rule number 1. This is very simple rule. No, we do not have any formula, nothing. It just make you understand about the root locus. That is called rule number 1. So it was given here. If you try to understand, for this diagram. So we have finished the rule number 1. The rule number 1 says that the root locus is symmetrical about x-axis. Okay, let's come to rule number 2. The rule number 2 says that we have numbered the poles as p and the zeros as z. Okay, so we have, let's say we have 5 numbers of poles. So the numbers are p1, p2, p3, p4 and p5. That means total number of poles are 5. Let's say we have some 3 numbers of 0. So in that case, the 0 is represented by z, z1, z2, z3 and the total number of z equal to 3. So here, as my poles are greater than zeros, we can write p is greater than zeros, or the number of poles are greater than the number of 0. So p greater than 0 does not mean the value of pole is greater than the value of 0, not like that. So total number of poles are greater than total number of 0. क्लियर, मतलब लाइक 10 पोल है और 6 जीरोज है, तो 10 पोल तो बड़ा होगा ना 6 जीरो से. तो अगर ऐसे नहीं बोला कि जीरो का वैल्यू क्या है, पोल का वैल्यू क्या है, नॉट लाइक दैट. सो देन टोटल द नंबर्स ऑफ ब्रांचेस ऑफ रूट लोकस इक्वल टू पी. अंडरस्टूड? एंड द नंबर ऑफ ब्रांचेस टर्मिनेटिंग एट 0 इक्वल टू जेड. So what I told you is like if my open loop transfer function do have p numbers of poles, it indicates we have total p numbers of root locus. फाइन. अगर कोई ट्रांसफर फंक्शन में 3 पोल है तो हमको 3 रूट लोकस मतलब 3 ठो डार्क लाइन मिलेगा. क्लियर? एंड द नंबर ऑफ जीरोज इंडिकेट how many numbers of root locus are terminating at zeros. ठीक है, तो जितने एक्चुअली में क्या बोला था. सो वी हैव स्टडीड अबाउट द पोल्स and zeros, I mean the like the root locus starts from poles and end in zeros. Fine. So we have studied about that it indicates, as I told you, root locus starts from poles. That means जितना भी poles होंगे उतना root locus होंगे. ये तो clear हो गया ना. So the numbers of branches of root locus is equal to p, which is nothing but the number of open loop poles. ये तो clear हो गया. And we have also studied that the root locus end in zeros. ठीक है. दैट मीन्स द नंबर ऑफ जीरो वी हैव नंबर ऑफ टर्मिनेटिंग रूट लोकस. अगर कोई ओपन लूप ट्रांसफर फंक्शन में दो जीरो है तो दो जीरो मतलब दो रूट लोकस एंड होगा दो जीरो में. क्लियर. तो you might have another question that as I told you the p is greater than z, that means number of root locus are greater than number of root locus terminating at 0. Then what about the remaining root locus? Okay, let's say the p equal to 3 and z equal to 2. It indicates p is equal to 3 means total 3 root locus, and z equal to 2 means 2 root locus terminate at 0. So what about the other root locus, the remaining one? The remaining one will end at infinite. Clear? Understood? Okay. So, and the number of branches terminating at the infinite is equal to p minus z, which I gave example over here. That 3 minus 2 equal to 1. So, generally we find that always p is greater than 0. This pole is always greater than 0. But there is also a condition where z is greater than p. That is possible if your numerator is greater than 0. I mean, if the numerator is greater than the denominator. So in that case, the number of branches of root locus equal to z. Okay, just opposite of that. So here the number of branches equal to p, and here the number of branches equal to z, and the number of branches terminating at the poles as p, and the number of branches terminating at infinite is the like opposite of that, that is 0 minus pole. So what happened here? So in this case your numerator is greater than, your numerator is less than denominator. It is a proper fraction. In case of proper fraction, the value or the roots of numerator, the number of root of numerator is less than the number of denominator, which we will get that numbers of poles is greater than numbers of 0. For this case, we have open loop poles which will indicate the number of branches of root locus, and the number of 0 which indicate the branches of root locus which terminate at 0. But what if the numerator is greater than denominator? It is opposite to this, na? This is because improper fraction. In that case, the number of roots of numerator is greater than numbers of root of denominator. So whatever we studied here, it will get just opposite of that, because here numerator and denominator interchange over here. Here numerator is less than denominator, here numerator is more than denominator. So everything, every technique remains same, but what it happened, it actually change the formulae. Okay, change the assumption. Fine. So let's go to next rule, which is rule number 3. What it say? A point on the real axis lies on the root locus. Okay, it is very important to remember. A point in the real axis में जो points है, it might lie in the root locus. What is the condition? So you need to remember this thing. A point on the real axis lies on the root locus. How? If the numbers of open loop poles plus zeros. That means the number of open loop poles and the open loop zeros on the real axis to the right side of that point is odd number. So it is a critical sentence to make you understand. I will make you understand by drawing. I repeat, रियल एक्सिस में कोई भी पॉइंट रूट लोकस का पॉइंट हो सकता है. कैसे? अगर उस पॉइंट्स को उस पॉइंट से राइट साइड को अगर ट्रैवल करोगे, अगर तुम्हारा पोल्स और जीरोस नंबर्स ऑफ पोल्स एंड जीरो ऑड नंबर होगा, तब दैट पॉइंट और दैट लाइन might be called as the root locus. Let me make you understand by a proper diagram. So let's say we have a S plane over here, and this S plane, we know this is the real axis, and this is nothing but my imaginary axis. Let's say I have a pole over here, I have another pole over here, I have a 0 over here, I have a pole over here, and I have a 0 over here. So here I can see clearly that we have 3 numbers of poles and 2 numbers of zeros. Okay, but as we told you, all the poles are the left side of the S plane, so system is stable. I don't bother about the zeros. Clear? So I can say it clear that here the poles plus 0, the sum of poles and zeros should be odd number. What is odd number? 1, 3, 5, 7. These are the odd number which is not divisible by 2. So let's say you are taking a point over here, this point, this intersection point. So from that point, if you travel to right side, how many poles and zeros are there? We can see clearly that we have only 1 zeros and 0 poles. Total number of poles and 0 equal to 1, which is a odd number. So I can clearly say that this point can be a root locus, can be a point in the root locus. Go for this point also. From this point, if you go right side, you can see same 1 0. That means odd number. So this point is also a root locus. If you go for this point, from this point you can see only 1 0. So this point can be a root locus. So it is very clear that from this pole to this 0, whatever you take the point over this line, all the points are the parts of the root locus, as because whatever point you take to the right of that point, we have odd number of poles plus 0. So this total line is a part of the root locus. Very clear for that. And I told you root locus starts from pole to 0. So direction of the root locus will be like this, from left to right. Clear? Okay. Now let me take a point over here. I am taking a point over here. If you travel from right side, from this point, I can see that I have a pole over here and I have a 0 over here. So sum of pole plus 0 becomes 2. 2 is not an odd number, it's an even number. So this point will not comes under the root locus. Similarly, this point also not comes under, this point also not comes under. So this total line will not the part of the root locus. Clear? तुमको कोई भी पॉइंट ले लो रियल एक्सिस में, उस पॉइंट से राइट साइड में चले जाओ और काउंट करो कितना नंबर्स ऑफ पोल और कितना नंबर्स ऑफ जीरो हो गए होंगे. टोटल नंबर्स ऑफ पोल्स प्लस टोटल नंबर्स ऑफ जीरो ऐड कर दो, जितना भी होगा, अगर वो नंबर ऑड नंबर है तो तुम जो पॉइंट अजम्पशन किए थे दैट पॉइंट इज ए पार्ट ऑफ अ रूट लोकस, or else it is not a part of the root locus. Similarly, if you take this point, from this point if you travel right side, we can see we have 1 0, 2 0 and 1 pole. So 1 plus 1 plus 1, 3. That means from this point if you travel right side, we have 3 numbers of poles and 0. 3 is a odd number. So I can clearly say that this point is the part of the root locus. Similarly, whatever the point in between this line, from this line to this line, so this line is the part of the root locus. Clear or not? Obviously it should be clear. And what is direction? Direction of the root locus starts from the poles and end in 0. So this is again the direction from left to right. Clear, guys? Okay. And what about this point? From this point, if you travel one pole, 1 0, one pole, 1 0. Total 4 numbers of pole and 0. 4 is a even number. So this point is not the part of the root locus. And we can see this total line will not a part of the root locus, because wherever you take the point, same thing will come to end. But what about this point? If you take this point to the right side of that point, we have 1 2 3 4 5. That means 3 poles and 2 0. To total number 5 numbers of poles and 0. 5 is clearly an odd number. So this point is a part of the root locus. And we can whatever, if you go to up to infinite, negative infinite, all the numbers or all the points becomes the parts of the root locus. And I told you root locus starts from the poles. So this is the poles and end in 0. But if it not given also, I assume that I have a 0 at infinite. So the direction of root locus will be from right to left. So I think this is very clear to you. If you are not able to understand, then please repeat this thing to make you understand. Clear? So this is all about the rule number 3. Let's go to the rule number 4. Okay. So rule number 4 says the P minus Z, the number of poles minus the number of 0 branches of the root locus terminate at infinity along certain straight line known as asymptotes whose angle are given by. So asymptotes के लिए एक formula होगा, and that formula will given by theta equal to 2q plus 1 whole into 180 degree divided by p minus z. Here p means number of poles. Pole का value नहीं है. Total numbers of poles minus total numbers of zeros. While writing in your notebook, you just write hash p minus hash z. That means number of poles minus number of zeros. So I repeat the rule number 4. The p minus z branch, मतलब what we studied, p number of poles means p numbers of branches, z numbers of 0 means z number of branches are actually terminated at the 0, and remaining branches which need to be terminated infinite, those numbers are p minus z, and that lines are actually the straight line. Okay, so those straight lines are called as asymptotes. And asymptotes always starts from the centroid. We'll study the formula of centroid. And from the centroid, with respect to real axis, it creates an angle. That angle is nothing defined by theta. Clear? And the formula for theta equal to 2q plus 1 whole into 180 degree divided by numbers of pole. I can write hash of poles and number of 0, that means hash of 0. Clear? And what is q? Q equal to 0, 1, 2, 3, 4, 5, 6 up to p minus z minus 1. Clear? अगर यहाँ पे p, let's say I have total number pole equal to 5 and I have total number of zeros equal to 2. Okay, so my q can be, how to find q? Q starts from 0 and end in p minus z minus 1. Here p equal to 5, z equal to 2, and I have a formula that is minus 1. So 5 minus 2 minus 1 equal to 2. So the q value are 0, 1, 2. So there is no hard rule for taking the q as many numbers. we need to consider the value, I mean the formula up to p minus z minus 1. So this need to remember. So if you go further also, they did not create any problem for your exercise. But why should, if you do not need those things, then why should go further? Clear? That means it is clear, it is given that as my q value changes, so here theta also changes. Clear? So how many asymptotes are possible? The points, I mean the root locus end in infinite, those are called asymptotes. So how many root locus end at infinite? The p minus z numbers of root locus end at infinite. So p minus z numbers of asymptotes are possible. Okay. So if you go further, rule number 5. Here I also have some example I given. So if p minus z equal to 1, so q equal to 0. Okay, because p minus z minus 1, so 1 minus 1 equal to 0, so q having only 0. Similarly, if p minus z equal to 2 and 2 minus 1 equal to 1, so q becomes start from 0 end in 1. Similarly, if you take the different value of p and z, you will get different value of q, and from this, by changing the value of q, we can get the value of theta. So different theta can be possible. So with respect to q, your theta can be possible. So here I have only one q, so theta becomes 180 degree. So along the real axis, and here theta becomes 90 degree and 270 degree. So this is the exactly perpendicular line. So this is the 90 degree line and this is the 270 degree line. Similarly, here p having theta having 60 degree, 180 degree and 300 degrees. So like 180 degree is a straight line and 60 degrees this line, and 300 degree also can get some line. So these are all about the rule 4. Okay, next rule 5 is the centroid. Okay, what is the centroid? I told you, from centroid the asymptote starts. Okay, so it is the point of intersection of asymptotes. That means if this is the real axis and here this is asymptotes and here this is another asymptotes, and this intersection point is called as centroid. We also have formula to find the value of centroid. So it may or may not be the part of the root locus. कोई गारंटी नहीं है कि ये जो centroid root locus का part होगा. So this can be a part of the root locus, but this cannot be part of root locus. Depend upon the position of the poles and 0 to the right hand side of the point. Clear? So if you go further, the formula for centroid, like the numbers of the real part of the open loop poles. Okay, I mean the summation of real parts of the open loop poles. Try to make it understand. The summation, I mean summation is addition. The addition of real parts of open loop poles minus addition of real part of open loop zeros. यहाँ पे in the numerator we consider about the value of poles and zeros, and in denominator we consider about the numbers of poles and numbers of zeros. Clear? Let's say p pole equal to 5 plus minus z2. So let's say p equal to 5 plus minus j2. That means we have two poles. One pole at 5 plus j2, another pole at 5 minus j2, and z equal to 1 only. So what it gives? The real part of the poles, p1 का real part क्या है? So p1 real part equal to 5 and p2 real part is also equal to 5. So from the centroid formula, how to get that? Centroid C equal to summation of real part of the poles. So 5 plus 5, जितना भी पोल्स होंगे सबका रियल पार्ट को सम कर दो, ऐड कर दो. So 5 plus 5 equal to 10 minus सम ऑफ रियल पार्ट ऑफ द ओपन लूप जीरो, यहाँ पे जीरो एक ही है और जिसका रियल सिर्फ रियल वैल्यू है वन, सो दिस ही बिकम्स वन, डिवाइडेड बाई नंबर ऑफ पोल, कितना पोल है, सो टोटल टू पोल्स है, टू माइनस how many numbers of 0, one number of 0, so this is 1, so this value becomes 5 plus 5 equal to 10, 10 minus 1 equal to 9, 9 divided by 1, so this is equal to 9, so मेरा centroid equal to 9, that means it lies at the right hand side of the S plane. Okay, so generally centroid does not lie with our problem because the system has to be stable. यहाँ पे एग्जाम्पल के लिए मैं एक समझा दिया, सो ट्राई टू अंडरस्टैंड विथ दिस एग्जाम्पल. ओके, so rule number 5 says that the centroid, I repeat, centroid is the point of intersection of the asymptotes on the real axis. Always centroid lies in the real axis, remember, and it may or may not be the part of the root locus, and the formula for centroid will be the sum of real part of the open loop poles minus the sum of real part of the open loop zeros divided by number of poles minus number of zeros. Okay, so the next lecture we'll study about the next rules and we'll study some problems also. Take care. Thank you very much. If you like the content, please don't forget to like, share and subscribe to Spark Study channel. Thank you very much.